Hello everyone, I am Siti Adawiyah. I am the first speaker of the next group. I'm going to tell you about basic types of speaking. So the first is imitative. Imitative is a purely while this is a purely phonetic level of oral production, a number of prosodic, lexical, and grammatical properties of language may be included in the criteria of performance, and the only role of listening here is in the short-term storage of a prompt, just long enough to allow the speaker to retain the short stretch of language that must be imitated. So here, the listening role is just a short-term storage. Next is intensive. So a second type of speaking, intensive, frequently employed in assessment context, is the production of short stretches of oral language designed to demonstrate competence in a narrow band grammatical, phrasal, lexical, or phonological relationship. The speaker must be aware of semantic properties in order to be able to respond, but interaction with an interlocutor or test administrator is minimal at best. So here, in intensive, the speaker must be aware of semantic properties in order to be able to respond or to answer the test. Next is responsive. So, responsive assessment tasks include interaction and test compatibility, but at this somewhat limited level of very short conversations, standard greetings and small talk, simple requests and comments. And like the stimulus are almost always a spoken prompt, like in order to preserve authenticity, with perhaps only one or two follow-up questions or retorts. So in responsive assessment, it's include interaction, but somewhat in a limited level of very short conversation. Next is interactive. So what is the difference between responsive and interactive? The difference between responsive and interactive speaking is in the length of complexity of the interaction, which sometimes includes multiple changes or multiple participants. In interpersonal exchange, oral production can become pragmatically complex with the need to speak in a casual register and use colloquial language, ellipsis, slang, or humor, and other socio-linguistic conventions. Next is extensive. So, what is extensive? Extensive oral production tasks include the speeches, oral presentation, and storytelling, during which the opportunity for oral interaction from listeners is either highly limited or ruled out altogether. The language style is frequently more deliberative and formal for extensive tasks, but we cannot rule out telling informal monologues such as casually delivered speech. So here, the language style is frequently more deliberative and formal. Next is micro skills. So this is micro skills that need to be included. First is produce difference among English phonemes and allophonic variants. 2. Produce chunks of language of different lengths. 3. Produce English stress pattern, word in stress and unstressed position, grammatic structure, and intonation contours. Produce reduced forms of words and phrases. 5. Use an adequate number of lexical units, like words, to accomplish practical purposes. 6. Produce fluent speech and different rates of delivery. 7. Monitor one's own oral production and use various strategic devices like pauses, filler, self-correction, backtracking to enhance the clarity of the message. 8. Use grammatical word classes like noun, verb, and etc. and system, for example, like tense, agreement, pluralization, and word order, patterns, rules, and forms. 9. Produce speech in natural constituents like in appropriate phrases, pause group, breath groups, and sentence constituents. 10. Express a particular meaning in different grammatical forms. 11. Use cohesive devices in spoken discourse. The next is the macro skill. So number 12, or the first number, is appropriately accomplish communicative function according to situation, participants, and goals. 13. Use appropriate styles, registers, implicature, redundancies, pragmatic convention, conversation rules, word keeping and yielding, interrupting, and other sociolinguistic features in face-to-face conversations. 14. Convey links and connection between events and communicate such relation as vocal as peripheral ideas, events, and feelings. New information and given information generation and exemplification. The 15th is convey visual features like kinesis, body language, and other non-verbal cues along with verbal language. 16. Develop and use a battery of speaking strategies such as emphasizing keywords, repressing, providing a context for interpreting the meaning of words, appealing for help, and accurately assessing how well your interlocutor is understanding you. The next is the designing assessment task for imitative speaking. So, imitative speaking in and on overall oral production assessment, as long as you or teacher artfully avoid a negative flashback effect such as pass range from word level to sentence level, usually with each item focusing on a specific phonological criterion, like in a simple word like repetition task. The taker repeat the stimulus. The stimulus can be word or sentence, whether it is a pair words, a sentence, or perhaps a question. So here is the example, like word repetition task. The task taker here, or the student here, and the teacher say, repeat after me, beat, and the student say beat, and then this teacher said but, and then the student said but, and then the teacher said I bought a boat yesterday. The student say I bought a boat yesterday. The glow of the candle is growing. When did you go on vacation? Do you like coffee? The taker repeat the stimulus. Next is a variation on such a task from test taker with a brief written stimulus which they are to read aloud. So it can be with the written stimulus which they are to read aloud, or it can be the teacher read it, so the student or the test taker will listen to it. And scoring specification must be clear in order to avoid reliability breakdowns. A common form of scoring simply indicates a 2 or 3 point system for each response. Like here, scoring scale for repetition task. Score 2 for acceptable pronunciation. Score 1 for comprehensible but fairly correct pronunciation, and score 0 for silent, seriously incorrect pronunciation. The next is the longer the stretch of language, the more possible for error. And therefore, the more difficult it becomes to assign a point system to the text. In such case, it may be imperative to score only the criterion of the task. For example, in the sentence, "When did you go on vacation?" Since the criterion is following intonation for web question, points should be awarded regardless of any mispronunciation. So I think that's all of my material. The next material will be delivered by my friend. Thank you.
Hi, I am Shofia Yulianisa. Here I am going to continue the presentation. Next is about natural language generation. You are probably familiar with computers providing warnings or help messages such as "file not found." These are examples of canned text, which the computer prints out in response to particular cases that it has been programmed to handle. Such systems do not use linguistic rules, and they cannot generate novel sentences. Natural language generation goes far beyond canned text. Natural language generation, a subfield of artificial intelligence, is a software process that automatically transforms data into plain English content. The technology can actually tell a story exactly like that of a human analyst by writing the sentences and paragraphs for you. There are two main steps in natural language generation: deciding what to say, called strategic generation, and deciding how to say it, called tactical generation. Here, strategic generation. In a strategic generation, the system must select specific content from a dataset and decide on the overall structure of the output, which can be as short as a phrase or as long as an entire document. The strategic generator specifies which message units will be included in the text and plans the structure or discourse model of the output text. Then tactical generation. In a tactical generation, the system generates sentences from the abstract message units specified by the discourse model. In the simplest case, each message unit may be expressed in a single sentence, but multiple messages can be combined in a single sentence, or a single message can be split across multiple sentences. The tactical generator applies information from the discourse model to make these kinds of sentence building decisions. Then next is probabilistic theories. Statistical analysis was initially discredited by most linguists. They argue that statistical methods are based on induction from small samples of an infinite language, and so they will misrepresent the language. But many linguists don't find the competence-performance distinction to be clear-cut. Sociolinguists in particular have argued that the variability of linguistic performance is systematic, predictable, and meaningful to speakers of a language. If statistical rules induced from example perform just as well as rules derived from intuition, then this suggests that probabilistic statistical linguistic rules might help explain or model human linguistic behavior. It also suggests that humans might learn from experience by means of induction using statistical regularities. Then now is related technologies. The impact of computational linguistics on society depends on the application it makes possible. Computers have for many years been using more computational linguistics tools in applications such as multilingual word processing, spelling correction, and grammar checking. These and other technologies provide opportunities to embed and apply computational linguistic methods. We focus on four related technologies here: information extraction, speech recognition, speech synthesis, and machine translation. Information extraction. The application area of information extraction tries to derive the semantic content of a document as a whole as it relates to particular types of events. Information extraction programs automatically fill out templates or tables from natural language input. For example, for terrorist events, the template slots to be filled may include the perpetrator, the victim, the type of event, and where and when it occurred. An information extraction program can extract the relevant content of hundreds of documents in the time it would take a human to read and extract the content of one. And then speech recognition. Speech recognizers are an off-the-shelf commodity and are found embedded in a variety of day-to-day applications, including telephone access to business service, transcription of speech for the hearing impaired, digital dictation, automatic multimedia information access, and more varied use. A speech recognizer uses a dictionary that lists pronunciation for words in its vocabulary expressed as sequences of phonemes. Variant pronunciation are generated by phonological rules in the form of probabilistic finite state transducers. They take advantage of the rich statistical information obtainable from a corpus to produce rules for recognizing a variety of combinations of sound as one and the same word. A speech recognizer uses several knowledge sources: an acoustic model, a pronunciation model, and a language model. The latter function as a synthetic recognizer. This speech synthesis system usually take written text as input and produce speech. Initial program tokenize text into words and pre-process them to detect proper names, numbers, abbreviations, and so on. Morphological disambiguation program sort out words whose variants are spelled the same but pronounced differently, like read, past versus present tense. The output of the tokenization preprocessing, lexical lookup, and morphological analysis program is a phonetic transcription of the text. The next step is to transform this written representation into sequence of actual sounds. Speech synthesis is valuable in many applications, including telephone access to business service, ads for the handicapped, education, toys, navigational system, and weather emergency bulletins. Then machine translation. Machine translation is one of the biggest application areas for computational linguistics. With millions of technical manuals, office materials, and other communication being translated daily. Unlike the translation of literary text, where a considerable amount of creativity is required on the part of the translator, machine translator is focused on translation that preserves the information content of the source language as much as possible, while rendering it in a natural form in the target language. Machine translation poses challenges to many areas of computational linguistics since it involves understanding utterance in one language and generation of utterance in the other. Machine translation systems all tend to translate sentence by sentence and, with a few exceptions, do so while ignoring discourse context. There are three general approaches to machine translation. A direct approach looks up word from the source utterance in a bilingual dictionary, chooses the most appropriate word translation by some method, and then records the chosen word translation based on the target language word order. This approach by itself doesn't lead to good result, to something like it is useful in translating between very similar languages. A transfer approach, which is the most widely used, requires three components: source language analysis transfer, involving grammar rules that map structure across the language based on constructive analysis of the two languages, and the target language generation component. An interlingual approach attempts to decompose the meaning of the source language utterance into a language-neutral conceptual representation from which the target language sentence is directly generated. In an interlingual approach, either the system represents one concept for every word in each language, or else the system decomposes meaning into supposedly universal primitives. This is the last submaterial from this chapter, Major Challenges in Computational Linguistics. While computer algorithms are very well understood, getting computers to acquire some of the linguistic and world knowledge needed by those algorithms is a major challenge. Even with the very large corpora now available, many of the problems in processing semantics and pragmatics depend on the computer acquiring vast amounts of linguistic and world knowledge. One strategy of current research is to balance quantity and quality of information from large corpora that are annotated or automatically annotated without human supervision, and therefore relatively expensive, is combined with information from smaller but more expensive sets of data that are annotated with human supervision. However, inferencing isn't easy for the computer, and general knowledge of the world, such as the principle that push cause false, is hard for a computer to learn from corpora. Common sense knowledge bases built by hand are very expensive to develop and must be meticulously enriched by hand for each new application area. Information extraction methods can acquire various facts about the world, but acquiring a machine interpretable knowledge based off common sense knowledge, let alone specialized knowledge in areas like biology and medicine, is a formidable undertaking. Okay, so that's all from us. Thank you for hearing, thank you for watching, thank you for your attention. Feel free to ask if there's some of our explanation that still unclear for you. Then wassalamualaikum warahmatullahi wabarakatuh.